next one is a simplified question. And to do simplified questions, you notice there's no equal sign. There's never an equal signs in simplified questions. We just multiply out. And we have 2x squared plus 7x minus 3x plus 12. Look at the middle. You see the 7x and the 3x, so we get 2x squared plus 4x plus 12. Now you can't divide by 2 because there's no equal sign, okay? So that's the answer, okay? And that's can't divide by 2. Now, solve for x and y. This is what we call a linear quadratic system, okay? So this is simultaneous equation. This is the linear one because it has no x squareds or y squareds in it. And this one here is the quadratic. Now what we got to do is we got to get one letter on its own in the linear. I'm going to get x on its own. So therefore x equals 7 minus y. I'm going to sub this 7 minus y in place of x in the quadratic formula. So what we're going to get is 7 minus y squared instead of x squared, okay? And 7 minus y squared is 7 minus y multiplied by 7 minus y. So now we have the x squared part done. Now we're looking for the y squared plus y squared. That's that part there. And then equals 29. And this is this part here. Now we can multiply out. 7 by 7, 49. 7 by y minus 7y. Minus y by 7 minus 7y. Minus y by y plus y squared. Plus y squared equals 29. Now, y squared plus y squared is 2y squared. Minus 7y minus 7y is minus 14y. Bring over the 29 over the other side, it becomes minus 29. 49 minus 29 is plus 20. Now, what we can see here is that everything is divisible by 2. So let's divide everything by 2. You could do the minus b formula if you wanted, where a equals 2, b equals minus 14, and c equals 20. But there's no need to do that, alright? So what we get here is y squared minus 7y plus 10 equals 0. The reference number is going to be 1 multiplied by 10, which just gives you plus 10. Now we need what these two factors of 10 have to add up to minus 7. So if we get 2 and 5, and we do minus 2 minus 5, minus 2 multiplied by minus 5 is plus 10, which is what we need, and it also equals minus 7. Now, because it's a 1y squared one, you can just throw these ones right into the bracket, and we know that's going to be the answer there. So it's going to be, put down a dotted line down the middle, and what we'll have next is y minus 2 equals 0. Either the first number equals 0 or the second number equals 0 when you're multiplying two numbers together, and the answer is 0. So either y equals 2 or y equals 5. Now, you're not done at this point because you still have to figure out what x is. And x is 7 minus y. Remember, we used that at the start. So x equals 7 minus y. X equals 7 minus 2, which is 5. Okay, y x, so that means that one set of values is going to be x is 5, y is 2. And then when y is 5, it's going to be 7 minus 5, x equals 2. So the other answer is going to be 2, 5. When x is 2, y is 5. Now, a rectangle has a length 2 root x centimeters and width root x centimeters. The length of the diagonal of the rectangle is root 45. So let's just draw a quick, maybe a quick diagram of what we're looking at here. Okay, so here's our rectangle. Okay, here's our diagonal. And what we know is that the length is 2 root x. So 2 root x is here. Root x is the width. And we know from here to here is root 45. Now what we also know about rectangles is this is 90 degrees. Okay? So what we can do is we can do Pythagoras' theorem. Okay? Now, so Pythagoras' theorem is the longest side squared. So using Pythagoras' theorem, it's the hypotenuse squared. The hypotenuse is the longest side. So it's root 45 squared equals the other side squared and added together. Okay, so you got to square them. Root x squared plus 2 root x squared. You got to square them and add them together. Now, what happens is root 45 squared is 45. Now, the exact opposite of square root is squared. So for instance, root 9 is 3. 3 squared is 9. This makes root 9 squared 9. In the same way that root x squared is equal to x, okay? So, what happens here? What happens here is we find out this is x, okay? Now the next thing is 2 root x squared is 2 root x multiplied by 2 root x. And we do what we always do. We multiply the normal numbers by zero. 2 by 2 is 4. And then we have to know what root x by root x is. And that's the same thing as 4 by root x squared. And root x squared is x. So that's just going to be plus 4x. Therefore, 45 equals 5x. X equals 45 divided by 5. X is equal to 9. Okay? Now, if the area of the square is twice the area of the rectangle, find the length of each side of the square. Now, we know that x equals 9. Okay? So what we can do here is basically say that, okay, this here is 9. And this here is 9. Okay? Put that into your calculator. You find out that that's 6 then. And you find that this one here is 3. Okay? Look at the keywords. Twice the area of the rectangle. Let's find out what the area of the rectangle is. Area of rectangle is length by width. That's 3 by 6. And 3 by 6 is 18. Okay? The area of a square is twice the area of the rectangle, so multiply that by 2, and what we get is 36. Okay? So the area of this square is going to be 36, okay? So we know that it's 36, and we know that the length and the width had to be the same. Therefore, y squared equals 36. Y must be the square root of 36. Y equals 6. The length and width of this square is 6. Now 6 centimeters. Just keep an eye on your units, okay? Next one. Differentiation. Now, what we say is that we let y equal x cubed minus 7x squared plus 6x. Now remember, when you're differentiating, what you do is you put the number to the front and you take 1 away from that number. So the y dx ends up to be 3x squared. Bring the 2 to the front. 2 by minus 7 is minus 14. Take 1 away from the power. It's x1, or just simply x. And finally, when you start off with an x, all that happens when you differentiate it is that number disappears. So you're going to get 3x squared minus 14x plus 6. Next one. We identify this as a quotient drill, where this is u and this is v. So what you're going to do is you're going to go to your tables, okay? And in your tables, you're going to go to the start of them and you're going to look up calculus. Calculus is on page 25. You go to page 25 of your book, and what you're going to see is y equals u over v. It's called the quotient drill. Therefore, dy dx must be equal to v du dx minus u dv dx all over v squared. Now don't worry about write your answer in the form k divided by x minus 2 to the power of n. Like, that's the way it's meant to look, but the bottom line is you got to differentiate this and then worry about this part second, okay? So what we're going to know is that u equals 3x plus 1. Now, what the u dx means is that you differentiate u. Differentiate 3x. When you differentiate x, an x value, like just x on its own with a number in front of it, it disappears. So the answer is 3. Differentiate any ordinary number and it disappears. So the u dx is 3. Now v equals x minus 2, or 1x minus 2. What this will do, it will make the v dx differentiate. The x disappears, comes 1, and then the 2 just disappears as well. So we know the u dx is 3 and the v dx is 1. Let's fill them in. So what we know about dy dx is now dy dx is phi. Phi is x minus 2. Phi's done. Du dx is 3. That's done. Put in the minus. Correct. U, which is 3x plus 1. Multiply by dv dx, which is 1. Okay. Now, in general, I like to put the number just in front of the bracket here, so I'm going to put the 1 in here instead. I'm allowed to do this because it doesn't matter when you're multiplying which one you multiply with first, okay? And then all over phi squared, which is x minus 2 squared. Now, looking at the answer, I can see that I'm not meant to square this out because it's meant to stay in its bracket. So that's what that form can do for you, okay? So you can say x times 3, 3x, minus 2 times 3, minus 6, minus 1 times 3x, minus 3x, minus 1 times 1, minus 1, all over x minus 2 squared. And what we have here now is 3x minus 3x cancel each other out, and we get that minus 7 on top and x minus 2 squared on the bottom. So we have minus 7 over x minus 2 squared. Now what this said means that it can be a positive or a negative whole number. Can't be a fraction, can't be a decimal, but it's allowed to be a minus number. K therefore is the top number, it's minus 7, and n is the power, n equals 2. And that's your answer. Okay. Next question. Now this question here is the chain rule, okay? Now to identify a chain rule, what's going to happen is the chain rule is you'll have a bracket, you'll have a power on the outside, and you'll have stuff within the bracket. So what you gotta do, if you remember how you differentiate, let's say you differentiate x to the power of 4. What happens is the 4 goes to the front. You take 1 away from the power, x3, and you get 4x3. But the difference is we gotta differentiate what's in the bracket as well. Alright, so we'll show you what happens when you do the chain rule. Okay, so it's exactly like what we just did. Dy dx, you bring the 4 to the front, you write out the bracket, you take 1 from the 4, you get 3. Now what you also got to remember, and what most people forget, is you got to differentiate what's in the bracket. So differentiate x squared, the 2 goes to the front, 2x, take 1 away from the power, so it's going to be 2x1, or simply 2x. When you differentiate a number that has only x in it, that number remains, so it's going to be so as we said, we got to differentiate the bracket once we do this. So differentiate 2x squared, you get 2x. Differentiate minus 2x, you get minus 2. And that's the end there. So what you got to also remember is that BOMDAS, right? Now BOMDAS says that if you imagine this scenario here, 3 multiplied by, let's say, 4 to the power cubed multiplied by 2. BOMDAS says that you got to do the brackets out first. So if we were to multiply in the 3 by the 4 first, and we got 12 to the power of 3, we're not allowed to do that, because it gives us a completely different answer. We have to square it out or cube it out first. So you're only allowed to multiply the 3 by the 2, and you can get 6 by 4 cubed. That's the only thing you're allowed to do. If you do the other way, if you multiply 3 by 4 and write down 12 cubed, you get a completely different answer. That's wrong. So remember, you can only, so when presenting these questions, you can only multiply the first and the last one. You have to leave the power alone. So this thing is protected, okay? Can't be touched in differentiation. So this is dy dx. So dy dx equals what's going to be ax. 4 times 2x is 8x. 4 times minus 2 is minus 8. 8x minus 8 into x cubed minus 2x minus 9. Sorry, x squared minus 2x minus 9 to be cubed. Now, the next thing we're aware of is that we have to put in x equals 2. So we have to replace all x's with minus 2's. So what we can do is this, 8 times minus 2, minus 8, brackets, brackets, minus 2 squared, minus 2 times minus 2, minus 9 cubed. Now, fairly big question, so maybe just want to do one bracket at a time. So this bracket here, call it the green bracket. Green bracket's going to be minus 24. Okay, we call this one the red bracket. The red bracket, we're going to get 4 minus 4, or say plus 4 minus 9. So that's just going to be minus 1, but minus 1 cubed. Okay, and minus 1 cubed is still minus 1, so the answer is going to be plus 24. Okay. Next one. A ball is rolled in a straight line along a surface. The distance in meters of the ball is given by s equals 18 multiplied by the time in seconds minus 2 times the time in seconds squared. Okay. Now when this happens, s equals distance. Remember, you're in a differentiation question, so differentiating is a very good idea. The SDT, when you differentiate, you get the speed. When you differentiate a second time, you get the acceleration. Okay, so just keep that in mind. First question asks for speed. So it wants the SDT when t equals 3. So let's find out what the SDT is. Okay, so s is going to be 18t minus 2t squared. Let's do the SDT. The SDT, remember the t disappears, comes 18. Bring the 2 to the front, comes minus 4. Take 1 away from the power, 4t. And we have to find out the speed after 3 seconds. So replace in 3, 18 minus 4 times 3, which equals 18 minus 12. That's going to get us 6. Now, it's in meters and seconds, so meters per second is the unit of speed. Okay, part 2. How far is the ball from the starting point when it stops moving? Now, when it stops moving, this basically means that its pace equals 0. Its speed has to equal 0. So the SDT, or its speed, has to be equal to 0. So this means that 18 minus 4t must equal 0. You could bring the 18 over the other side and you get minus 4t equals minus 18. Same thing as 4t equals 18 when you change the numbers on both sides. Divide 18 by 4. So t equals 18 divided by 4. And what we should get there is 4.5 seconds. Okay. Now, part 3. How far is the ball from the starting point when it stops moving? It takes 4.5 seconds for it to stop moving. So we have to see how much distance it covers in 4.5 seconds. The distance is equal to 18 times the time minus 2 times time squared. So it takes 4.5 seconds to stop. So the distance covered in this time is going to be 18 times 4.5 minus 2 times 4.5 squared. And what we get, just put that straight into the calculator. So all of this right here just goes into the calculator exactly as it looks. And please remember your brackets, very important. And we get is 40.5 meters. Now, next question. Show that the speed of the ball decreases at a constant rate. Decreases at a constant rate while it is moving. Okay, show that the speed of the ball decreases. So the speed of the ball decreasing is basically the deceleration or the acceleration, right? Deceleration. Okay. So what we have to do is we have to get the second derivative, and make sure that there's no variables in it. The word constant means that it doesn't change with time. Okay, so what we're going to have to do for part 3 is we know that the first derivative is 18 minus 4t. So the SDT is 18 minus 4t. And then what we do is we get the second derivative, which is the acceleration or the deceleration. And whether we know it's acceleration or deceleration, we'll know by whether it's a plus or a minus. The 18 turns to 0, and the minus 4t turns into minus 4. And what we realize that it has a deceleration of minus 4 meters per second squared. So it decelerates by 4 every time. Okay. Next one. List the 5 steps to differentiate from first principles. Okay. I am sure there's 5 steps, but we'll go through the steps anyway. F of x plus h. That's myself. I write the 2 of these down first. So I'd go 1, 2, and then my third step would be f of x plus h minus f of x. My fourth step would be f of x plus h minus f of x all over h. And perfectly enough, my fifth step would be, I gotta write all these steps down, the limit as h approaches 0 of f of x plus h minus f of x all over h. So that is 5 steps, okay? Now, what we're asked to do is we're asked to differentiate from first principles 2x squared minus 5x. Now, first principles means we got to do it out the long way, this routine. So f of x equals 2x squared minus 5x. Now, the difference between f of x and f of x plus h is anywhere you see x, you must replace it with x plus h. So it's going to be 2 times x plus h squared minus 5 times x plus h. Now, that's the same thing as writing 2 times f of x plus h by x plus h, that's x plus h squared, yeah, minus 5 times x plus h. Now what I gotta do is gotta multiply this out, so it's gonna be 2 times, what we'll do here is just multiply these ones first, x squared plus hx plus hx plus h squared minus 5 x minus 5h. Okay. Now, what we gotta do next for f of x plus h minus f of x, and I'm just gonna need a shade bit more room here. Okay. So I'll just highlight this area down here. Just move it down. That's not it. Move it down here. Okay. So what we're going to get here is 2x squared. To 2 of these add together to give me 2hx in the bracket. 2 multiplied with 2hx is plus 4hx plus 2h squared minus 5x minus 5h. Now, okay, so this next part here, what we gotta do is we gotta put in, let's see, oh, it's all stuck together here. Okay, so what we gotta do next is we got to write down f of x plus h minus f of x. Now all of this part here is all f of x plus h. It just all belongs to this part here. So we gotta write down as 2x squared plus 4hx plus 2h squared minus 5x minus 5h. Now we also got a minus f of x, so minus 2x squared minus 5x. Okay, 2x squared minus 5x. Now what's going to happen here is that's going to make it, you're multiplying it by minus 1 basically, so it's minus 2x squared minus 5x. And what's going to happen here is it'll cancel with these, so this one, That's a plus, by the way, because minus 1 times minus 5x is plus 5x. The minus 5x and plus 5x cancel out. The 2x squared cancels with the minus 2x squared. And what you're going to be left with is basically 4hx plus 2h squared minus 5h. Okay? Now, if you were to test this at the start, when you differentiate this, usually the 2 goes to the front, and you're going to be left with 4x. The 5x disappears, so it's 4x minus 5 is the answer we're expecting. And you can see it's sort of taking shape here. The 4x and the 5 are here, okay? So what we have to do is we have to divide everything by h. So when you divide everything by h, what's going to happen is the h will cancel with this, will cancel with one of them, because that's meant to be hh, which leaves one h remaining, and cancels with the 5. So what you're going to be left with is 4x plus 2h minus 5. And if you read the last step, it's the limit, move there, the limit as h approaches 0. So all h's turn to zeros. This means that the 2 here is going to be 2 times 0, and that's going to leave us 4x minus 5. And this means the first derivative, dy dx, equals 4x minus 5. Exactly what we're expecting. Okay, now the next part. We've got to do a back-to-back stem and leaf plot for the above data, for maths and science. Okay, so what we're going to do is we're just going to draw 2 big lines here. Okay, and what you got to do is you got to measure what is the lowest values and what is the highest values. Okay, so the lowest values is, we're just going to have a quick 27 is what's popping up at me. No, 25 is lower. So 25 is 25 the lowest. Just scroll down through everything. 25 is the lowest math result, and the lowest science result is going to be 36 at the moment. Still 36. So because 20 is the lowest, now we've got to look for the highest. 91 obviously for science, or for maths. I don't see anything higher. And in science I do believe it was 85. We'll just have a look now. 85 is the highest in science. So we got to go from 20 to 90. Okay, so 20 to 90. So we're going to go 2, 3, 4. This is the stem we're doing now. 6, 7. We've got to extend this line a bit further. Okay, 8 and 9. 8 and 9. Okay, now we call this one side maths, and this side here is going to be science. Now what we got to do is we got to list off all the numbers. Okay, so starting off in 20s, we have 25 and 27. So 25 and 27 is going to be 5 and 7. Okay, now we're into the 30s. We have 38, 38 and 30. Okay, so 38 and 30, which get me 30, 38. Now we're into the 40s. Okay, no more 30s I see, so now we're into the 40s. And I see 45, 2 45s, and nothing else, so it's going to be 45, 45. You go back up again. Now time to go into the 50s. So we have 52, 53. So 2, 3, 4, 5 and 9. So 2, 3, 4, 5 and 9. 2, 3, 4, 5 and 9. It's good to keep it in line. Okay, so you basically know, you can get a look at the quantity of the ones you're doing. Okay, so that's pretty important. Okay, so that's a 2 there. Now we're on 6, 60s. 5, 7 and 9. 65, 67 and 69. So it's going to be 5, 7 and 9. Then we're going into 70s. 3, 1, 3. Just 1 and 3. Now we're going into 80s. Just 3 and 6. and we know that the maximum there is 91. Okay, so 91. Now, the next thing we're on is science. We're starting off, there's no 20s, but there is 30s, okay, so we'll try and look out for the 30s. 36, no other 30s, so just 36, okay. So straight away we're noticing that the minimum value of science is a lot higher than maths, okay, so the lowest value in science isn't as low as the lowest value in maths. Now we're into the 40s. We have 40, 45, 47 and 48. So 0, 5, 7, 8. 0, 5, 7 and 8. Okay. That's all the 40s gone. Now we're on to 50s. 51, 55, 58. So 1, 5 and 8. 1, 5 and 8. Now we're on to the 60s. 62, 4 and 7. So 2, 4 and 7. Okay, now we're on to the 70s. 72, 74. Oh, and we forgot, just 1 second. We forgot another 64, so we had two 64s, okay, so just be careful not to make that mistake. So 60, I'll redo that last one. Okay, so I had 247, it should be 2447. So this is where the striking part comes in. It really shows up the errors as they happen, alright? So 2447, and I left out 65 as well, so not on the best roll here at the moment. So 2, 4, 5 and 7. Okay, so let's change that to 5 and 7. Okay, now there's a secondary check I'll do in a few minutes to show you how you can also find these errors before you do anything else. 72, 74, 75, 76, 2, 4, 5, 6. 72, 74, 75 and 76. Right, cross all 70s. And then we're left with 83 and 85. Now, a way to check out if you've done the right amount or not is, first of all, we can count how many people we have in total. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, there's 19 people in this class. So 19 people equals 19 results. So let's say we have 19 results. Okay, that's one result. This part here is 4 results. This part here is 3 results. Now, this is just a check, okay? You don't really draw it like this in the exam, but I'm going to show you how this will come in useful in a second as well. This part here is 5. This part here has 4 results. And this part here has 2 results. Add all those numbers up together and make sure that you get 19 out of it. So you get 5, 1 plus 4, plus 3, plus 5, plus 4, plus 2. It's 19. So we've checked that, it's correct. Now let's go up and look at the blue distribution here. Okay, so we have 2. Okay, technically speaking, we have another 2 here. We have another 2 here. And then it just goes up. Okay, and then we have 2, 2, 2. We got 5 here. We've got 3 here. And then we've got 2, 2, and 1. So you just have to add up all them, make sure they add up to 19 as well. So you're going to have 6 plus 5 plus 5. So it's 2 plus 2 plus 2 plus 5 plus 3 plus another 3, and we get 19. So according to ourselves, we've included everybody in this. Okay, now what you just do is you just do that with maybe a pencil or whatever and just get rid of it then, okay, quickly afterwards. Okay, so next thing, how many students took the examinations? 19 students. Okay, because it's 19 students per class. Okay, so each student took both maths and science. This results in maths and science for a class. So for class means it's the one class. Okay, so 19 students there. Okay. Next part. What is the range of marks in science? Okay, so the range of marks in science is basically what is the top value minus the bottom value. So range, this is not included in your tables, by the way. It's top mark minus bottom mark. If you go to the last page, you can tell from your stem and leaf what it is. It's going to be 85, which is this one here, and 36 is the bottom one. So it's 85 minus 36. So 85 minus 36 is 49. What is the interquartile range of the science marks? Now interquartile range means interquartile range. Now what it means is it means interquartile means the difference between the student who's 1/4 up and the difference between the students who are 3/4 up. So what we need to do is we get 19 people and we multiply it by 1/4, and this finds out what Q1 is. Q1 is called the first quartile. So we're going to find out who actually is the first quartile. Okay, so 19 multiplied by a quarter is 4.75. You always have to round up when doing interquartile ranges and mediums. So it's the fifth person. Okay, so what we do is we go back and we go to science. Now, there's one thing that we left out on this diagram while we're here. We left out the key. Okay, and the key is this. CF25 here. You have to write down 52 equals 25. To get full marks, you got to write your key. And on the other side, the key is, let's say 36. 3/6 equals 36. It's very important you write down your keys. Okay. Now back to the question we were just on. The first quartile is 19 multiplied by a quarter, which is 4.75, which is the fifth person. This is for the science marks. So let's go to the science tree, the science lemon tree, and let's go up 5 people. 1, 2, 3, 4, 5. It's 48. First quartile is 48. Okay. Now we gotta do is the third quartile. Q3, or the third quartile. And what we gotta do here is we gotta multiply 19 by 3/4 and figure out what that is. So 19 multiplied by 3 divided by 4, and what you get is 14.25. You gotta round it up to 15, so it's the 15th person. Okay, so let's find the 15th person in this stem and leaf plot for science. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. He's on 74. He or she is on 74. Okay. He or she is on 74. So what we write down is 74. So the interquartile range is Q3 minus Q1. So interquartile range is going to be 74 minus 48 is 26. State one difference or one similarity between the two distributions. Okay, so let's look at the distributions. Now, let's see, one similarity. Now, I'm trying to look for similarities here. One difference is we can obviously see that the range in maths is going to be a lot higher. Okay, so if we were to put down the range of maths, so difference we go for the range of maths. Difference, range of maths. Range of maths is higher. Okay, so it's more distributed. Okay, so the range of maths would be 91 minus 25, and that'll give you 66. Okay, and that's compared to 49 in science. Okay, now one similarity. Well, one similarity is that they both use 19 tests. Like there's 19 tests in each one. So I can say that's a similarity. 19 tests in each distribution. Uh, Now I'm trying to see what else we could put down. Another difference is more students in maths get lower than science. For example, 4 people got in between 20 and 40, while in science only 1 person got below 40. Uh, the most common marks or the mode would be 60s, in the 60s for science, but in maths it'll be in the 50s. So trying to find another similarity. And our similarity would be the same amount of people got in between 80 and 90%. So 2 people got in between 80 and 90% in science, and 2 people got in between 80 to 90% in maths. So similarity, 2 people in both subjects got between 80 to 90 marks. Okay. It's between the 2 distributions, okay? Now, we could also have a look at, yes. If you were to draw like a curve going across, okay, you see that the maths is a bit like more symmetrical looking, while the science so they're sort of similar enough. The maths is more skewed, has a big mode in the middle, so it's very hard to make a comment about the actual overall shape, so I'd stay away from that in the exam. Okay, next question. Okay, one shelf in a library has 70 books of poetry and drama, either hardback or paperback. Students select one book at random from the shelf. Find the probability that the book is a paperback poetry book. Okay, so add all the books together and you get 23 plus 17 plus 14 plus 16. Okay, so you have 23 plus 17 plus 14 plus 16. There's 70 books in total. So paperback poetry book would be 17 out of 70. Make sure that it doesn't break down anymore. It doesn't. 17 out of 70. A hardback book, add the 2 of these together, you get 37. Okay, so it's going to be 37 out of 70. A poetry book is 23 plus 14. 23 plus 14 for poetry, that'll get you 40 out of 70, which is 4/7. And finally, not a paperback drama book. Not a paperback drama book is 1 minus the probability it is a paperback drama book. Okay? So the probability of it being a paperback drama book is 16 out of 70. This means that 54 out of 70 of them aren't a paperback. So it's going to be 1 minus 16 out of 70, which is 54 out of 70. Now, okay, so we're on to skewing now. Okay, so identify the following types of distributions. Okay, so we got to mention the skew and give a real life example of each. Right, so this one here, you can see that in general the higher values are up here. So let's say if the number like 90 was up here, the number 20 be down here. So this is what's called a negative skew. Okay, so the first one, A, is a negative skew. Okay, now we have to think of something We have to give a real life example. So what gets greater the bigger the number gets, okay? So maybe and gets bigger as you get older. What about your height? Something like your height from, let's say, 10 to your height from 0 to, let's say, 30 years old, maybe. That gets bigger every year. Or maybe your height, maybe because it levels out at the end, we don't want to stop there, so maybe your height from 0 to 16. Okay? So height from 0 to 16 years old. Okay? Another one could be how much money you make. These are years you left after college and how much money you make. So the longer you're out of college, usually the more you make. Now, this one here is what we call a positive skew because it's falling down. It's fallen down to the higher value. So this is called a positive skew. Okay. Now, we need something that gets smaller as something else gets bigger. Okay, so I'm trying to think now. Example of a positive skew would be positive skew. The number of children in the family, maybe that could be one example. The age at which people learn how to ride a bicycle, because most people learn how to ride a bicycle early on in life, or the age at which people marry. So the older you get, the less likely you are to get married, like 70, 80 years old. Okay. Another one for a negative skew could be the ages at which people have to get their first pair of reading glasses. You get more reading glasses as you get older. Or maybe another example of a negative skew would be the height of players playing in professional basketball league. Most of the players are getting taller. Okay. Now, another one. This one here is called a symmetrical distribution. Symmetrical distribution, okay, so it's not skewed at all. Now, an example of symmetrical distribution is, let's say, heights of random people, heights of a population, IQ of a population, and yeah, heights and weights and maybe the IQ of a population has a symmetrical distribution, okay? Now, a bag contains 5 red and 3 yellow discs only. When a disc is drawn from the bag, it is returned before the next draw. What's the probability that the 2 draws will yield both yellow discs? So 5 and 3 is 8. So probability of a red is 5 out of 8. Probability of disc is 3 out of 8. Now, the word and means it's going to be multiplied. Both of them had to happen. So 3 over 8 to get the first yellow disc, and 3 out of 8 to get the second yellow disc will get you 9 out of 64. What's the probability that the 2 draws will use both discs from the same colour? So you can either have 2 reds or 2 yellows. And what we know about 2 yellows is it's 9 out of 64. But 2 reds, however, is going to be 5 out of 8 for the first red, and a second red, which is another 5 out of 8. Multiply them by each other and you get 25 out of 64. Now the OR rule comes in. Okay, OR means, AND means multiply, OR means add. So we can have red, red, or yellow, yellow. So that means a big plus sign there, and we get 25 out of 64 plus 9 out of 64, which is 34 out of 64. You won't get full marks for that now because it's not fully broken down. 17 out of 32. Okay. The table below shows a frequency 0, 1, 2, 3 goals scored in a number of football matches. Okay. So the first question says, if the mean number of goals scored in match is 2, find the value of x. Okay, So what the mean is the mean is 2. Okay, so mean equals 2. Now, what mean is the average. Mean equals total goals scored, total goals divided by number of matches. So the total goals scored is 0 multiplied by 1, which is 0. 1 multiplied by x, which is x. 2 multiplied by 1, which is 2, because one match had 2 goals in it, and 5 matches had 3 goals, so that's 15 goals. And this is divided by the number of matches, which is 1 plus x plus 1 plus 5. That's going to be 7 plus x. Okay? Then what we're going to get is we need to tidy up the top, so it's going to be x plus 17 divided by 7 plus x equals 2 over 1. The mean is 2. Cross multiply. Bring the 1 up there and bring the 7 plus x up here. And what we're going to get is x plus 17 equals 2 multiplied by 17 is 4 plus 2x. Okay, bring the x over this side, and what we should get is 2x minus x. Bring the 14 over the other side, we get 17 minus 14, and we should get 3 equals x. X equals 3. Okay, and all the workings are there. Now, the game consists of a biased, unbiased arrow on a square board and showing an unbiased dice. Now, the unbiased arrow has 4 possibilities, okay? So there's 4 possibilities of this, and dices, okay, so the dice has 6 sides, okay? So the dice will have 6 sides, so it has 6 possibilities, okay? List all the possible outcomes. There's going to be 24 different outcomes because it's 4 multiplied by 6, okay? So let's write down what we could have. We could have A1, A2, A and a 3 on the dice, A and a 4 on the dice, A and a 5 on the dice, and A and a 6 on the dice. There's 6 of them. B1, B2, B3, B4, B5, B6. Let's do the same thing again. C1, C2, C3, C4, C5, C6, and last one D1, D2, D3, D4, D5, and D6. Okay. It's all the possible outcomes that is spinning the arrow and throwing the dice. Okay. Now, after that, we got to answer some questions. Okay. And the questions are: find the probability that in any outcome it will be an A or a 6. A and a 6. In any one game, the outcome will be an A and a 6. And means it has to be both. A6 is what we're looking for. A6 is one answer out of 24. It's one answer out of 24, so it's 1 out of 24. Okay? So it's 1 out of 24. It's also the probability of getting an A is 1 out of 4, and the probability of getting a 6 is 1 over 6, and that gets you 1 over 24. Find the probability that the outcome is a B and an even number. Okay, so what you can do is you can go back. B and the even number would be 1, 2, 3. 3 out of 24. Okay, so that's 3 outcomes out of 24. So it's going to be 3 out of 24, which equals 1/8. The other way of doing that is outcome is a B is 1 and 4. Multiply by and, so it's multiplied by even number. Even number is a half. So that's going to get you an 8. Okay. Find the probability that the outcome is A or B, and an odd number. Okay. So A or B and an odd number. So there's A1, A3, A5, and there's B1, B3, and B5. Okay. So we got to add them together. Or means you got to add them. Okay. So what we're going to get is 6 out of 24, which is a quarter. Okay, because there's 6 possible outcomes. Find the probability that it will be C or D and a number greater than 4. Okay, so that would be C4 because it's greater than or equal, C5, C6, D4, D5 and D6. That's going to be 6 out of 24, which once again is going to be a quarter. Once again R, so it can be C or D and a number greater than or equal to 4. Okay, now final question on this, the correlation coefficient. So what we're looking at is, now if you're to put a line through this, it's very hard to know where to go because there just simply ain't any correlation. Okay, so the correlation there is very low. You might say describe the following correlations and estimate. So description is weak, no correlation actually. Okay, so there's just no correlation, and no correlation is anywhere from, let's say, 0 to 0.2, just nothing there. Okay, next one we can look at here is correlation here. Okay, so what we have is a negative correlation, I think. Okay, and this is a strong negative correlation. Okay, so strong negative. Now what negative means is that it goes as you go from, it gets, one of them gets higher as the other one gets lower. Okay, so for instance this is a low value, but yet this one up here, the y value is high. Now for a high x value we have a low y value. This means it's a negative, so a strong negative correlation. Okay, now it's basically nearly a perfect straight line. Okay, so it could be anywhere from correlation coefficient, I reckon, of let's say 0.8 plus. Okay, so I'd probably go from 0.8 minus 0.8 because it's negative. Okay, so minus 0.8 minus 0.08 to minus 1. That's how strong it is. Okay, so remember. Okay, and this the first correlation coefficient was 0 to 0.2. Okay, now this one here is a positive correlation, and it's like a moderately strong correlation. Okay, so this is a strong negative correlation. To be honest, it's near enough perfect. Okay, so we will just say moderately strong. Strong positive. It's positive because as the x value gets bigger, so does the y value. Okay, so it's a moderately strong positive correlation, and if we're given a ballpark range, I'd say anywhere from 0.6 maybe to 0.75, somewhere around there, maybe even higher, 0.8. Okay, so 0.6 to 0.8, somewhere in that range. Okay, the next one you can sort of see it's sort of has a negative left, so it's a moderate, just like an average, to be honest. A moderate, not even moderately strong, a moderate negative correlation. I'd say anywhere maybe from about 0.4 to 0.6. I'd actually probably give it slightly higher than that now, actually, even about, I'd say about 0.5. Okay, not too weak. Okay, so there's some correlation there. Okay, it's not too bad, about 0.5. Okay, now this one here is a strong positive correlation, near enough perfect, right? So it's a very strong positive correlation. Oh, this is negative, so it's minus 0.5. Negative correlation minus 0.5. These ones are positive correlations, and that's a negative correlation, and this one here is a positive correlation. So very strong positive correlation. I reckon that would be 0.85 upwards, right? So 0.85 to 1. It's almost perfect. Okay, it wouldn't be 1, but it'd be 0.85 upwards. Okay, 0.85 plus, in around that ballpark, in around that area. Okay, And that is the end of this revision video.